Example 1, solve this system by graphing. Okay, so to solve the system of equations by graphing, it's very simple. You graph both lines. Wherever those two lines intersect is the answer. If the lines happen to be parallel, bless you, if the lines happen to be parallel, the solution is empty set. If the lines have to be exactly the same line, the answer is all real numbers. If the lines go like this, which is more common, the point where they cross is the answer. Typically we get one answer. As far as I know, when you solve by graphing, in this book, every answer should have, just a regular ordered pair answer. So if we focus first of all on the top equation here, 3y minus 2x equals 6. If I want to graph a line, slope-intercept technique is the most efficient for graphing. So I'm going to get this to say y equals. So first thing I'm going to say 3y equals 2x plus 6. You take the negative 2x, slide it across, becomes positive 2x, getting y isolated on the left-hand side.
Should that be?
Go ahead.
Or says 3x.
Yours says 3x?
Oh wait, my bad. I'm wrong page.
All right. So now does it say 2x?
Yes.
All right. Okay. So 3y minus 2x equals 6. So 3y equals 2x plus 6. So the 2x moves across, becomes positive 2x. Divide everything by the coefficient of y. Divide everything by 3. 3 divided by 3 divides out, so we get y equals, what I have here is 2 over 3x plus 2. Once I get the equation in slope-intercept form, the constant 2 is the y-intercept, and the slope of positive 2/3 tells me every time I go up 2 spaces, I got to go right 3 spaces. Up 2, right 3, up 2, right 3, and I create these dots. Connect those dots with a nice straight line, because we always, when we graph a line, we always connect the dots. We end up with this line as the top equation's line. Any concerns on that? Moving right along. Y plus x equals negative 1. Okay, if I change that to y equals, it's going to be y equals negative x minus 1. Now, notice this time the y-intercept is negative 1. It's normal. My slope is minus. Okay, minus x, right? So minus is the slope. Okay, remember there's a 1 understood in front of the x, so the slope is actually negative 1. We like slope to be a fraction, so putting it over 1 just to create that fractional look allows us to see exactly what we're supposed to do. Negative 1 over 1 tells me to go down 1 space every time I go right 1. Okay? For my purposes, for me graphing specifically, I always make sure the bottom number is positive, so I'm always going right. Then I just have to worry about up or down. Positive up, negative down. So negative 1, down 1, positive 1, right 1. Down 1, right 1, and so on. And we connect these dots with a nice line, and we will get the other line. So that green line there represents the other line. Okay, the point of intersection of these two lines represents the answer. We can see the point of intersection is right there. It's not right at a pretty number, it's just kind of in the middle there, right? Let me just get a little closer view of this. I don't know how my board works. Okay. Right here is 0, 0. All right. I'm going left 1, left almost 2. Right? So the coordinates of that, the x coordinate would be about, maybe about negative 1.8. Oh. I guess we can't write and have that at the same time. Negative 1.8 for x. And then looking at it again, what do you think the y is? Right here is 0, right here is 1. 0.8, 0.9, somewhere in there. All right. Let's just say 0.9. It looks closer to 0.9 to me. That's an approximate answer. Okay? That's me using my eyes and my own estimation abilities to predict what it is. That's a pretty decent guess. If I had guessed the answer was 6, 2, that's not a very good guess. 6, 2 is over here. Okay, get me close and you'll be fine. It's between negative 1 and negative 2, closer to negative 2. Between 0 and 1, closer to 1. Those numbers are fitting that description. So make your guess close to the right answer. It doesn't have to be perfect. All right? that's job one. Solve by graphing, we just solve by graphing. I graph the lines, they intersected around that point, that looks like a good answer. There's the solution to the problem by graphing. Now the other part of this problem says check the solution by using either substitution or elimination. Alright, substitution or elimination, which would you prefer to use here? Elimination works for me. We got y, x equals number. The structure is better for elimination. I've got a negative 2x and an x, so if I just take this bottom equation times 2, positive 2x, negative 2x are going to cancel. So I'm going to keep 3y minus 2x equals 6, exactly as it is. I'm going to get 2y, helps to write the right letter there, 2y plus 2x equals negative 2 for the second equation. Be careful when you use elimination that every number gets multiplied. So 2 times y, 2y, 2 times x, 2x, 2 times negative 1, negative 2. Be careful that all the objects get multiplied. 3y plus 2y is 5y. Negative and positive 2x cancel. 6 minus 2 is 4. We divide both sides by 5. We get 4/5, better known as 0.8. We got 0.9. Okay? The whole idea of elimination and substitution, we're getting the exact right answer now. It should be very, very close to our approximate answer. It might not be exactly the same, but close. And 0.8 and 0.9 are very close. And we can make an argument that looks like 0.8. I think Kayla might have even said that. I wanted to put the wrong number on purpose just so we could see it doesn't really matter if this is right, just as long as it's close. So y equals 0.8. Then, to find x, I got to go back. I take this answer and I replace that in one of the equations up here. I'm going to put it right there where y is. So 0.8 plus x equals negative 1. Subtract 0.8 over here. These have the same sign, so I add them together, and they're both negative, so it's negative. Notice the x answer is exactly right. So the exact right answer is that. So when it asks you to solve by graphing, that's what I'm expecting to see on your paper. I want to see the graph, I want to see your point of intersection, I want to see what you guessed your answer to be. And then I want to see your elimination or substitution technique to determine the exact answer and actually write exact next to it. If your answer here happens to match your answer here, that's fine, that's allowed. Still write exact next to the one you did with the elimination and substitution method. Okay?